the question. For centuries, we've looked up at the night sky and wondered the same thing. Are we alone? The stars look so still and silent that it's easy to imagine we might be the only ones. But in the last few decades, the picture has changed completely. We now know that planets are not rare, they're everywhere. Hello and welcome to Astrobitica, your home for space news and information. Here we turn the vast mysteries of the cosmos into stories you can actually follow, remember, and share. Before we begin, make sure to subscribe and tap that notification bell so you never miss another journey beyond Earth. Since the 1990s, astronomers have confirmed thousands of exoplanets, planets orbiting stars beyond our sun. The first discoveries were revolutionary. Suddenly, what once existed only in science fiction became measurable fact. Today, we've cataloged more than 5,600 confirmed planets, with thousands more awaiting verification. And with every new discovery, our understanding of the galaxy and our place within it keeps evolving. How we find other worlds. Finding an exoplanet is hard. Imagine staring at a searchlight from miles away and trying to spot a tiny moth flying across it. Planets are small, faint, and easily lost in the glare of their parent stars, yet astronomers have found clever ways to uncover them. One of the most effective methods is called the transit method. When a planet crosses in front of its star from our point of view, it blocks a tiny fraction of that star's light. The star dims slightly, sometimes by less than 0.01%, and then brightens again as the planet moves on. By measuring those subtle dips with telescopes like Kepler and TESS, astronomers can determine a planet's size, its orbital period, and even detect hints of its atmosphere. When light from the star passes through that atmosphere, certain wavelengths get absorbed, chemical fingerprints that can reveal the gases present. Another powerful approach is the Radial Velocity Method. As a planet orbits its star, its gravity tugs on the star just enough to make it wobble. The wobble shifts the star's light spectrum back and forth, slightly redder, then slightly bluer, in a repeating pattern. Even though we can't see the planet directly, we can see its gravitational signature. Together, these techniques have transformed astronomy. They've shown us that planets aren't exceptions, they're the rule. Virtually every star you see in the night sky likely hosts at least one, the habitable zone. Of course, not every planet can support life, at least not life as we know it. So astronomers focus on worlds in what's called the habitable zone, the region around a star where temperatures are just right for liquid water to exist on the surface. Too close to the star, and water boils away. Too far, and it freezes solid. Earth sits comfortably in the Sun's habitable zone, and so do several intriguing exoplanets we found elsewhere. One of the most famous is Kepler 452b, often called Earth's cousin. It's about 60% larger than Earth and orbits a sun-like star within its habitable zone. Then there's the TRAPPIST-1 system, just 40 light-years away. It has 7 Earth-sized planets, 3 of which lie in the habitable zone, a miniature solar system that could host multiple potentially life-friendly worlds. And the closest of all is Proxima Centauri b, orbiting the nearest star to our Sun, just over 4 light-years away. It sits in its star's habitable zone as well, though its host is a red dwarf, smaller, cooler, and far more active than our Sun. Each of these worlds could, in theory, have oceans, atmospheres, or even climates not too different from our own. Finding a habitable planet is only the beginning. The next step is detecting life. Astronomers search for biosignatures, chemical clues that might indicate biological activity. On Earth, the combination of oxygen, methane, and water vapor in our atmosphere is a dead giveaway for life. Alone, each of these gases could come from non-biological processes, but together, in the proportions we see, they are almost impossible to maintain without something living to replenish them. Future telescopes, like the James Webb Space Telescope and NASA's proposed Habitable Worlds Observatory, will analyze the atmosphere of nearby exoplanets in unprecedented detail. They'll look for those same telltale mixtures, the chemical fingerprints of life. And while we search with light, others search with sound, or at least radio waves. Projects like SETI, the Search for Extraterrestrial Intelligence, scan the skies for narrowband radio signals that nature rarely produces on its own. So far, we've heard only silence. But the universe is vast, and our listening time has barely begun. What do these discoveries mean? Every new exoplanet we find answers one question and raises 100 more. If life could arise here on a small rocky planet orbiting an average star, why not elsewhere? There are an estimated 100 billion stars in our galaxy and possibly trillions of planets. Even if life is rare, the odds seem to favor company. But the search isn't only for finding neighbors. It's also about understanding ourselves. Studying other planets helps us see Earth in context, how climate, atmosphere, and orbit shape a world's destiny. It may even teach us how fragile habitability really is. How we're moving forward. Right now, the hunt for life is accelerating. The James Webb Space Telescope is already measuring the atmospheres of exoplanets, detecting molecules like carbon dioxide, methane, and even possible hints of water vapor. The European Space Agency's ARIEL mission, planned for the coming years, will survey hundreds of exoplanets to understand how atmospheres form and evolve. And in the decades ahead, new observatories might go a step further, using direct imaging to separate the light of an Earth-like planet from the overwhelming glare of its star. In that light, we may someday read the chemical story of an alien biosphere. So when you look up at the night sky, remember this. Every point of light you see is a star, and most of those stars almost certainly have planets. Some are scorched deserts, others frozen worlds, but a few may be temperate, blue, and alive. Right now, we stand at the edge of discovery. For the first time in history, we can not only ask if other worlds exist, we can find them. And soon, we may learn whether life, perhaps even intelligence, has blossomed somewhere else in the galaxy. Maybe we really are alone. Or maybe, just across the dark, there's another world where someone is looking up and wondering the same thing. If you learned something new today, give this video a thumbs up and subscribe to Astrobitica. Tap the bell so you never miss our next cosmic deep dive. Until next time, keep looking up and stay curious.